Hello and welcome back to math class. You will notice that we ended last time with lesson 11. We did the first part of it, so today we're going to finish lesson 11. It's on S43 in your blue math book. We're not going to answer this top question right here because we kind of discussed it in yesterday or the last lesson that we did. We're going to go ahead and move on to part B. Now, if you remember, Part A, we compared these three students and we compared their grape juice. Well, today we're going to look at these three students, and this time it says we're going to compare their apple juice. And we want to do, this time it says, the next day each of the three people made juice again, but this time they were making apple juice. Whose juice has the greatest water to juice concentrate ratio, and whose juice would taste the strongest? Okay, so if the juice has more water in it, it's probably not going to taste as strong as the person who's going to have the strongest taste has a lot of juice in it and less water. So let's look at our tables and see if we can do some comparing. Last week we highlighted some things where there were common numbers. See if you can find any common numbers here with our waters. I don't see any common numbers. I do see some common numbers with juice. So if you have a highlighter, I want you to go ahead and find those sixes. And I'm going to go ahead and highlight the whole row. So right now it looks like both Milton and Franca have 6 cups of juice. Milton has more water than juice. So Franca's is probably going to be a little bit stronger. How am I going to attempt to get Laredo in this? Laredo doesn't have any common numbers. However, if you would take your pencil and circle this number 2, if I would want this 2 of my juice to match the 6s that I have over here, what would I need to multiply it by? I would need to multiply it by 3. And if I multiplied it by 3, I would have a 6. Let's put the 6 up here. Well, obviously, whatever I do to this, I have to do to this side. So we're going to multiply this by 3, and I'm going to get 36 for a total of 42. So if I could squeeze that down in between these, I would, but we're going to look here. Now I'm going to go ahead and highlight. Here's my matching 6. Wow, look at Laredo's. 36 cups of water compared to 6 cups of juice. Well, down here it says put the juices in order from the strongest apple taste to the weakest. Well, the strongest is going to be the one that has more juice than the rest. Well, all of them have 6 cups of juice. So now we need to look at the water. Go ahead and put them in order of who you think has the strongest. Hopefully you put first Franca. Franca had only 15 cups of water, Milton 16, and Laredo 36. So our next person will be Milton. Laredo's is not very strong. It has a lot of water. All right, so down here it says explain how you use the values in the table to determine the order. Well, if you think about it, we actually compared the ratios. We made a ratio where we made common numbers of 6 for the juice. So we actually did that. So what I'd like for you to go ahead and write down is this, please. Okay, so what I have here is that I compared the ratios 15 to 16, 16 to 6, and 36 to 6, and found the value of Milton's ratio, Milton, to be larger than Franca's, and Laredo's to be larger than Milton's. If you need to pause the video, you can do that so you can get this written down. Otherwise, we're going to go ahead and move down to here where it says what ratio was used to create each table. So if we look at Laredo, the smallest ratio that I found was right here, 12 to 2. Well, if I put 12 to 2 right here, we should be able to reduce that. Find the value. Well, they're even numbers, so we can divide them both by 2, and if we do, the answer is 6 to 1. Franca's 15 to 6. And of course, if I look at these, I can reduce these. There is a common factor. The common factor happens to be a 3. So 15 divided by 3 is 5, and 6 divided by 3 is 2. Milton, 16 to 6. If you look at your factor sheet, or if you know your facts, you will know that these are both even numbers and can be divided by 2 as well, like up here. If I take 16 and divide it by 2, it's 8. And 6 divided by 2 is 3. Now, if you notice, this is a lot different than our grape juice one. Our grape juice one, we had 1s in all of these spots, and we don't have them. So looking at the values is kind of difficult to compare them. So that's why we made a common fact or number up here in our ratios. Okay, turn over to the next page. So explain how the ratio could help you compare the juices. Well, if you think about it, we were able to compare the ratios when we made a common number. As long as the ratios have a common number, I can compare the juices. All right, the next one says, how was this problem different than the grape juice question in part A? Well, if you remember, the grape juice in part A had values that all had a common value of something to 1. So, for example, we had 3 to 1, 4 to 1, 5 to 1. And so this was easier for us to compare. This is obviously 5's larger than 4, which is larger than 3. And all the ones were common. All right, let's move down to problem C. Problem C says Max and Sheila are making orange juice. Max has mixed 15 cups of water with 4 cups of juice concentrate. Something we might need to know right there. Sheila has made her juice by mixing 8 cups water and 3 cups of juice concentrate. So I'll use a different color for hers. Compare the ratios of juice concentrate to water using ratio tables. State which beverage has a higher juice concentrate to water ratio. So we're going to draw some tables. All right, so the first thing we're going to do, if you notice, I made Max and Sheila, and I made a ratio table here. It's got 2 rows, and I have 4 across, and I have the same thing for Sheila. So draw that first. Make sure you label the top of the tables Max and Sheila. And then we're going to go ahead and make a ratio table. The first box we have to do when we make a ratio table is we kind of have to put our title, or we have to label it. And we're going to go ahead and put here, we're just going to put JC, and the JC will stand for our juice concentrate. And then we'll put down here water. And we'll do the same over here for Sheila. All right, so if we look up at the top, we're talked about Max. We have 15 cups of water and 4 cups of juice concentrate. So 4 goes up here, and 15 goes with our water. We're going to count by 4s across the top. And we'll count by 15s along the bottom. Okay, so we added 15 each time, and on the top we added 4. Sheila's ratio is 8 cups of water and 3 cups of juice. So 3, we're going to count by 3s on the top, which would be 6 and 9. Counting by 8s down here would be 8, 16, and 24. And if I look at my tables, I don't really see any juice that have the same number, or even water. So since Max has already 12 cups of juice. Let's go ahead and add another box over here for Sheila. Now, if I count by threes, 3, 6, 9, the next number is a 12, which is helpful because now we have a matching number. So let's fill in the missing number down here, counting by eights. Now I can actually compare Max, who has 12 cups of juice, and Sheila, who now has 12 cups of juice. If I look at them, it says state which beverage has a higher juice concentrate to water. Who has more juice? Well, they both have 12 juice. But Max has 45 cups of water and Sheila has 32. So whose is going to taste stronger with juice? It's going to be Sheila because she has less water. Okay, so I went ahead and wrote here, Sheila has a higher juice concentrate to water ratio. And we've proved it right here in our table. Okay, now if you notice, even though we made nice tables, we had to extend Sheila's so that we were actually able to compare. Let's look at our last problem for today. Victor is making recipes for smoothies. His first recipe calls for 2 cups of strawberries and 7 cups of other ingredients. Okay, so we're going to need to know that information. His second recipe says that 3 cups of strawberries are combined with 9 cups of other ingredients. Okay, so another one here. Which smoothie recipe has more strawberries compared to other ingredients? Use ratio tables to justify your answer. So once again, we're going to make some ratio tables. Okay, so this time you noticed I kind of went ahead and put my 2 tables right here, one on top of each other. I had a little bit more room just in case I have to extend my table. So I have the same thing. I did 2 rows of 4. So if you could make this in your book, make sure you label one recipe 1 and the other one recipe 2. Recipe 1, we are comparing strawberries and other ingredients. So let's go ahead and just write here, straw and other. Those will be our labels. Okay, recipe 1, 2 cups of strawberries and 7 cups of other. Well, we'll fill in counting by 2s. 2. Count by 7s, 7 times 1, 7 times 2, and 7 times 3. Add 7 each time. Our next one is 3 cups of strawberries and 9 cups of other. So go ahead and fill this chart in, counting by 3s. Do our other ingredients by counting by 9s. Now, look very carefully, and is there something we can compare? Do we have any numbers that are alike? I do see them. I see we have 6 strawberries up here in recipe 1 and 6 strawberries in recipe 2. So let's look at the question. Which smoothie recipe has more strawberries compared to other ingredients? So look carefully and tell me which one. Well, if I notice they both have 6 strawberries, that's the same. I want this, but if I notice the other ingredients, recipe 1 has 21 other things, and recipe 2 only has 18. And so to me, this recipe 2 has more strawberries compared to other ingredients than recipe 1 does. So I wrote over here on the side, recipe 2 has more strawberries compared to other ingredients. So go ahead and write that down, and then you have an assignment for you guys to fill in. I hope you guys have a great evening, and I will see you all tomorrow.